Good morning. Today we are working on CO31. We are determining if two ratios form a proportion. Oh, you know what? And if I remember right, I need to try to recalibrate. It wasn't letting me recalibrate the last time. So it's going to be off. Yep, it's still not letting me I don't know why it's not letting me recalibrate. Yeah, so it's gonna be a little wonky when I write. You're just gonna follow along the best that you can, and if you have questions, make sure you ask, okay? So, to determine if two ratios are a proportion, we need to know what a proportion is. So, a proportion, okay, yep. So let me go way up here. Ooh. Equivalent, that's an E. A proportion is equivalent fractions ratios and rates. Okay, so proportion is equivalent, and I've forgotten an equivalent. I messed up. Yeah, I messed up on how to spell it, but that's because I'm throwing by it's not calibrated. So equivalent fractions, rates, and ratios and rates. So each of the following is a proportion. Here are 5 ways that we can prove it's a proportion, that they are equivalent. So the first one is a scale factor with multiplication. So it's the scale factor with multiplication. So how did we go from 3/4 to 9/12? What was the scale factor that we multiplied by? Vivi? Say it louder. Times 3. So our scale factor was those 3's. That's one of the easy ones. We've worked with those scale factors, right? We know how to multiply up. Look at our next one. This one is scale factor with division. And there's an I in there. I can't squeeze it in. Division is spelled wrong. Throw an I in before the O. Okay. So 3/4 to 9/12. What scale factor am I dividing by? Eleanor? 3. So this time, instead of multiplying up, we're dividing back. That's supposed to be an arrow. Dividing by 3. So we're dividing by 3, going backwards, right? Because sometimes we don't know what we multiply up by, so we divide backwards, right? So the proportions could be multiplying up or dividing back. You get the same equivalent fractions. So we know that they are proportions. Do those two make sense? Okay, our next one is simplifying. So 3/6 to 4/8. Oh my goodness, how do I know that those are proportionate, that they are equivalent? Well, 3/6 I can simplify that down. What would 3/6 simplify down to, Christina? 1/2. 4/8 simplify down to, Amala? 1/2 again. So 1/2 equals 1/2. So sometimes you look at the two fractions and you go, there's nothing similar about this. I can't multiply or divide up. Mind blown, I can simplify them down to the same fractions. Ooh. Okay, so that's our first 3 ways to prove that we are proportionate. Scale factors multiplying up, scale factors multiplying down, or simplifying them down and they are equivalent fractions. Okay? Now, the next 2, this is not easy trying to erase this. All right. Next 2. We have cross products and decimal values. I have a note from last year that I switched them. So let's do, no, we can just keep it like this. So this, I'll go up higher. Cross products. So cross products means that we multiply on the diagonals and they're going to equal the same. So if we have 25 times 114, what do we get? Who has a calculator out? No, 25 times 114. 2,850. Now we do 15 times 190. What is 15 times 190?
200. It's the same thing.
Oh my goodness. It is 2,850. They're the same. So we know that they are proportionate because those cross products, when we multiply on the diagonal, they equal the same number. Okay? So that's how cross products work. If they don't equal the same number multiplying on those diagonals, they are not proportionate. So we could have even looked at that, looking at the simplifying one that's above it. 3 times 8 is 24. 4 times 6 is 24. Right? So using those smaller numbers, we know we could have simplified it down. You can use any of these to prove that fractions are proportionate. Okay? So some are easier to use than others. Some we just look at it and we just kind of know. Okay? But any of these ways will prove it. So doing the cross products, if we look at the scale factors with division, 3/4 to 9/12. Well, 3 times 12 is 36. 9 times 4 is 36. So even with the small numbers, it still works. Christina, are you working, paying attention? The last one we have is, that's a goofy D, decimal values. To find the decimal values, we take our numerator, we divide it by our denominator. So what is 8 divided by 7? Christina? 1.14. What is 28 divided by 24.5? You're not even doing it, but what would it be if you used your calculator, Beckett? We know I said that these were proportionate, so it's the same, 1.14. So if we divide them, we get the same decimal value. So if we looked back up here, what is 15 divided by 25? Who has a calculator out? What's 15 divided by 25, Michael? 1.6. What is 114 divided by 190?
0.6.
See, we can use any of these 5 ways for any problem. Some are easier to use than others, right? Some we look at those numbers, we look at 3/4 to 9/12, and we know we're multiplying by 3. We can see it right away. The bigger, crazier numbers, it's not so easy to see. So we do something like cross products or decimal values. You can use whichever one you want, doesn't matter. All 5 get you the same answer. So let's look at our assignment for today. Using 2 of the methods discussed on the front side, determine if the values are proportional. Show your work. Show me what scale factor you're multiplying by. Show me what you get for cross products. Okay? Prove to me that it works. So let's do this first one together. 4/5 to 20/25. First question is, are they proportional?
Yes.
So I'm going to use 2 methods to either prove they are or prove they're not. So what method should I use for my first method? Abby, what should I use? Okay, what would I multiply by? So if I multiply by 5, I would get 4 times 5 is 20, 5 times 5 is 25. I would actually write it out. It's really hard with it not being calibrated. But I would write out that 4/5 times 5 equals 20/25. Okay, what would my second way be? What do you think I should use, David?
Cross products.
Okay, oh shoot. 4 times 25 is what?
100.
What is 5 times 20?
100.
Oops, I just wrote it on top of each other. Okay, so they both equaled 100. So would I answer yes or no? Are they proportionate? I would answer yes. But I showed it 2 ways. I did multiplying scale factors and I did it with my cross products. Show your work so I can see easily which method are you using. Doesn't matter which method you use, they will all get you the same answer. Okay? Any questions on how to do this? Then we have word problems that we have to do. Let's look at the first one. A juice recipe requires 5 cups of orange juice for every 2 cups of water. To make the recipe for a group at summer camp, the counselor mixes 5 cups of orange juice with 30 cups of water. Will the juice taste the same as the original recipe? If not, what will be different? So what do you think the first thing I need to do is? Michael? Write out those ratios, right? So I have 5 cups of orange juice over 2 cups of water. And I'm going to label them, but it's too hard with my wonky pen, but label it so you can match them up. 5 cups of orange juice over 2 cups of water. Then that gives me 45 cups of orange juice over 30 cups of water. First thing I'm going to check, are they proportionate? I'm going to use any of those 5. I'm going to use the scale factor. How do I go from 5 to 45? What do I multiply 5 by to get to 45? 5 times what would be 45? Robbie?
9.
9. 5 times 9 is 45. So if I'm multiplying by 9, is 2 times 9 30? No! So the top one was OJ, right? Oops. Yeah. I can't with my wonky pen. Orange juice, is that gonna be a lot more than the water, or is the water gonna be a lot more? So if it was 5 times 9 to get to 45, but it's 2 times 15 to get to 30, which one has more to it? The water. So it's going to be, so the question is, will the juice taste the same as the original? No, it's not proportionate. Second question, if not, what will be different? Well, there's too much water. It's gonna be too watery. Does that make sense? Because I multiply by 9 and I multiply by 15, I can tell there's gonna be a lot more water than there is juice. So make sure you answer both questions if there's multiple questions. Eleanor,
Do we have to show 2 ways or just one?
on the word problems, I'm looking for the answers.
Oh,
Okay. Any other questions? And then we have our time for review. So it's just reviewing what we've already been working on. David, what was your question?
do we have to do time for review?
Well, of course we have to do all the things on the page. Every time we do the whole entire page. Any other questions? Okay, if you are watching this at home, I hope you are well, and I hope to see you soon. Have a wonderful day.
Yeah.